Okay, so this is section 7.1. This is your first assignment. And we're going to be talking about area between curves. And the examples I'm going to work are going to go a little bit farther than the one you need to do, so I suggest you look at the instructions. What I'm trying to do is set you up for future also. Okay, so area between curves. Let's take a look at what we're dealing with. So I've got two functions. This is f of x. And I've got another one here, which we will call g of x. As you can see, it's a straight line. And the area between these two curves is right here, shaded in red. And you notice we intersect at 2 points, A and B. So in order to find the x coordinates of those points, you set f of x equal to g of x, and then solve for x. And that gets you your A and your B. And what we're going to be doing here is definite integration. We've been doing indefinite, by and large, with differential equations. We're going to go back to definite now. Okay, so let's take a look at what we've got here. So let's come back in, and I'm going to break this thing down into two graphs to show you how this works. So here is f of x, and we're looking at between points A and B. So the area under f of x is just the integral from A to B of f of x dx. And that is this area right here, which, as you can see, includes part of the area we're interested in, which is this red area up here. Okay, so we've got more than what we need, but now I want to come back down then and let's sketch g of x. And we've got the same idea here between A and B. And remember, f of x is sitting up here. So the integral, or the area under that, is going to be the integral from A to B of g of x dx. This is the basic definition of what an integral is, area under a curve. So that gives us this blue area right here, which is this area right here. And at this point, you should be able to see what's going on. So the area that we're interested in is the area under F minus the area under G. Or it's the integral of f of x dx minus the integral from A to B, these are definite, g of x dx. Or in other words, it's this whole area minus the area that's just under g. So in general, it's going to be the integral of the top curve minus the integral of the bottom curve. And that will give us the area in between the two curves, which is what we want. Okay, so that's the theoretical basis behind all of this stuff. So let's work a couple of examples and see what these look like. All right, so example number 1. F of x equals x squared minus 6x. G of x equals 0. And the first thing we need to do is find the intersection. So I set f of x equal to g of x, or x squared minus 6x equals 0. I'm going to factor an x out. So I'm going to find x equals 0 and x equals 6. So this will be my A, and this will be my B. Okay, now it's always good to sketch a graph of what's going on here. And f of x looks like this. Should go through this point. This is 0, this is 6. So this is f of x. And g of x equals 0 is our x-axis, so this is g of x. So the curve we're interested in, or the area we're interested in, is in red. So you'll notice that in this one, my g of x is on top. So to set this up, I'm going to be dealing with then the integral of g of x dx minus the integral of the bottom curve, which is my f of x dx, from a to b and from a to b. Okay, so we know a and b, so we start plugging in what we know. So I'm going to have the integral from 0 to 6, and g of x is 0 dx. Now, in some cases, they will combine these two integrals. So I can also write this thing out, and I want to do it in this case, and I'll show you. I think you'll see why here in just a bit. So what I'm going to do then, now remember we split these things up, you can also end up combining them. We'll have the integral from a to b of g of x minus f of x dx. Alright, so we've got the integral from 0 to 6 of 0 minus, and I've got x squared minus 6x dx. Okay, or 0 minus anything, so I'm going to have a negative, the integral from 0 to 6 of x squared minus 6x dx. And I'm going to go ahead and split this on up, so it's going to be negative the integral from 0 to 6 of x squared dx minus 6 times the integral from 0 to 6 of x dx. And then we just re-wop these things. So I'm going to have negative. The integral of x squared dx is x cubed over 3. And that's going to be evaluated between 0 and 6. It's going to be minus 6 times, or excuse me, if I do this, this is going to give me x squared over 2, so it's going to give me 3 x squared evaluated between 0 and 6. And 6 cubed, excuse me, is 216 over 3. Minus, and then I plug my 0 in, that gives me a 0. Minus 3 times 36 minus 0. Or negative 216 over 3 is 72. minus 108. And I end up with 36 is the area under the curve. Okay, as you can see, a big part of this, again, is just bookkeeping, keeping track of negatives, keeping track of what you're doing. And remember, when you do definite, it's this one plugged in minus that one plugged in. Okay, so let's work another example. This one's a little bit harder. So on this one, you've got f of x equal 3 times x squared minus x. And g of x equals 0. So to find our point of intersection, we set them equal to each other. So we're going to have 3 times x squared minus x equals 0. Divide by 3. I have x squared minus x equals 0. I'm going to have x times x minus 1 equals 0. So x equals 0. X equals 1. Are 2 points of intersection. Now let's come back in and graph this guy, and something funny happens. And I deliberately did this to show you the importance of actually graphing it. So when we graph this guy, I end up with something which looks like this. From -1 to 1. And so this is my f of x. And the reason is because we've got a plus and minus 1 here. And here is my g of x. So I actually have 2 regions I'm interested in. I've got this region, and I've got that region. Okay, so what we need to do here then is break this into 2 parts. So in this one, I have my f of x on top. And you notice it goes from -1 to 0. So let's go ahead, and then on this one, I have my g of x on top. Now, if you're sufficiently smart on this, you should know that these are the same. So what I'm actually going to get is twice this guy. But let's go through and do this the long, hard, excruciating way, which you're going to have to do on some of the other ones, because it illustrates how you set these problems up. So the first thing I want to do then is do this one where I have my f of x on top. So it's going to be the integral from -1 to 0, because this would be a, and then 0 is going to be b. And my f of x is on top, so I'm going to have 3 times x squared minus x minus 0 dx. Okay, and I'm going ahead and bring this out because 3 times 0 is 0. This obviously we don't need. That gets me this one. Now on this one, my g of x is on top. So I'm going to have a plus the integral from 0 to 1 of 0 minus 3 times x squared minus x dx. And if you remember, if you flip these things, you get a negative. But let's go through and continue to work this on out. So what I'm going to have here then is 3 times the integral from -1 to 0 of x squared minus x dx. And we re-swap each one of these individually. And then the 0 goes away. I'm going to bring this minus out, so I'm going to have a minus 3 times the integral from 0 to 1 of x squared minus x dx. Now you notice I've got the same integral inside on both of them, but we've got different bounds of integration. So let's do this. X squared is going to give me x cubed over 3. So let's do I'm going to factor my 3 out. So I'm going to end up with an x cubed over 3, and this is going to be evaluated from -1 to 0. Shoot. Yeah. And I've already made a mistake here. It's when I set up the original problem. This should be x cubed. And this should be x cubed. And this should be x cubed. And that's why this didn't work out right. That was my problem. So now I'm going to have x squared times, or x times x squared minus 1 equals 0. I'm going to have x equals 0. And then I'm going to have x equals to plus and minus 1. So that gets me my 3 points. All right, and when I did my integration down here, I screwed this up because this should be x cubed, and this should be x cubed, and this should be x cubed, this should be x cubed, and I'm pretty close, but not quite there. So this is going to give me x to the 4th over 4, evaluated from -1 to 0, minus, and this gives me x squared over 2, evaluated from -1 to 0. And then I'm going to have minus, and remember I've gone ahead and I'm going to factor both of these 3's out front. So I'm going to have a minus, and then I'm going to do this guy, and I've already done it. So I'm going to have an x to the 4th over 4, and that's evaluated from 0 to 1, and that's going to be minus x squared over 2, and that's evaluated from 0 to 1. Okay, so now we come in, we've got all of this stuff. So I'm going to plug my numbers in. So when I plug 0 in here, I'm going to have 3 times 0 minus, and then I plug a -1 to the 4th is 1. It's going to be minus 1/4 minus, and I'm going to do the same thing here, 0 squared, that's 0 minus 1/2, and that gets me the first part, and then minus, now I'm going to have plug 1 in, so I'm going to have 1/4 minus 0 minus 1/2 minus 0. And so now I come back in and I'm going to distribute all of this stuff. So I'm going to have 3 times 0 minus 1/4 is going to give me -1/4 minus a -1/2 is going to give me a plus 1/2. Then I'm going to have another minus 1/4, and then I'm going to have a should be a minus 1/2, I think. Minus and minus. Yeah, there should be a minus here. With that minus, that's going to give me a plus 1/2. And then combine like terms, -1/4 minus 1/4, that's going to give me 3 times 1/4 minus 1/4 is going to give me -1/2. And 1/2 plus 1/2 gives me 1. And then we keep on going, so I'm going to have 3 times 1/2, which equals to 3/2, which is our area. Okay. Now, one more example here. And this one is really kind of different. because we can also integrate. Now, the previous two examples I integrated with respect to x, but we can also integrate with respect to y. And this problem is going to show you why you might want to do that. Okay, so my equations on this are x equals, that's the first indication, 4 minus y squared. So here you see my y is my independent variable, which is what we normally will integrate across. And I got x equals 2y minus 2. So to find our points of intersection, we set the two equal to each other. So I'm going to have 4 minus y squared equals y minus 2. And I'm going to bring this over. That gives me 4 equals 2y squared plus y minus 2. And now subtract my 4 over, so 0 equals to y squared plus y minus 6. I could factor this guy. It gives me y plus 3, y minus 2, or my points of intersection are y equals to a negative 3, and y equals to 2. Are my 2 points of intersection. Then I'm going to plug these in because we're going to need our x points also, because on this one the instructions are integrate with respect to both x and y. So all I do is I take my y point here, I'm going to plug it back in up here. So I'm going to have a negative 3 minus 2, that's going to give me negative 5, and then 2 minus 2 is 0. All right. Now some funny things happen on the other one, but you end up with the same thing. But let me show you why we need to do this. So the next thing I want to do then is I'm going to graph these two. So I've got my A and B points for both x and y at this point. Okay, this is algebra 2, up to here. So when we graph this guy, what I end up with is a line which runs through like this. And this thing runs out to 4. And then comes back, and this is 2, and this is negative 2. And then it comes on around. So here's a point of intersection, and here's my other point of intersection. So this point is my negative 3, negative 5, and this point is my 0, 2. So let's do the hard way first, which is where we integrate with respect to x. And to do that, I need to solve these in terms of y. So first we're going to do part A, which is integrate with respect to x. So I've got to solve these. So I'm going to start with this guy. Move my y squared, so I'm going to end up with y squared plus x equals 4. Or y squared equals 4 minus x, which gives me y equals to plus and minus the square root of 4 minus x, where this is the plus square root of 4 minus x, and this is the negative square root of 4 minus x. It's on bottom. Okay, this one's a little bit easier to solve. Basically, I just add my 2 over, so I'm going to have, the other one is going to be y equals to x plus 2. And we've already solved for our x and y bounds. So what I do now then is we're going to integrate this. Let's take a look at our area. And you'll notice this is really funky. because I actually have two areas. Up until this point, over here, all right, and this is the area we're after right here, colored in red. I have my G, or the, the x plus 2 is on top. And the negative square root of 4 minus x is on bottom. On this one, I've got this on top and this on bottom over here, which is from 0 to 4. So we've got two different integrals we need to set up here again. So let's do this. So the first one then is going to run from -3 to 0. I'm going to have an integral from -3 to 0. And I'm going to have my x plus 2 on top. So it's going to be x plus 2. And then I'm going to subtract the negative on bottom. So that's going to end up a negative, and a negative is going to give me plus square root of 4 minus x. And this is all dx. So this gets me basically this part of the area right here. All right? Because we've gone -3 to 0. So now we're going to have to go from 0 over to 4. Okay, so then we're going to have plus the integral from 0 to 4. And you notice the plus 4 minus x is on top, so we're going to have a square root of 4 minus x minus a minus this. That's going to give me plus square root of 4 minus x. I'm saying, now the reason is this thing's symmetric. So if we get the top, then the bottom is just twice that. And I'm going to rewrite this a little bit now. So I'm going to have the integral from -3 to 0 of x dx plus 2 times the integral from -3 to 0 of dx plus the integral from -3 to 0 of, and I'm going to go ahead and rewrite this because this is a use problem, 4 minus x to the 1/2 dx, where this is your u. And I'm not actually going to do all of this integration. Okay, so this is all of this guy. And then this is all going to be plus 2 times the integral from 0 to 4 of 4 minus x to the 1/2. Since I have two of these. Okay, so when you do all of these, you're going to re-wop these. This is a u sub, okay? And remember, it's this minus this evaluated. So when you set all of this up, you end up with 125 over 6. I'm going to let you calculate this. And this is how you do this thing with respect to x. Now, the reason this is not the likely one is, as you can see, we got real tricky in that I had to split this into two regions here and here. Now, however, if I do it with respect to y, we're going to turn this thing around. So basically, if I do it with respect to y, then my left curve, or the top one, then is always going to be the line, and the bottom one is always going to be this guy. So what we can do then is come back in, and now let's do this thing with respect to y. Or excuse me, the other way around, yeah. I want to have this minus this. Okay. Now we've already got our y bounds. So I want to come back over here. And we still got this same picture. But let's clean this up a little bit for our purposes with respect to y. And that should go through this point right here. So now the area I'm interested in is right here. And we're integrating with respect to y, so we're going to integrate from -3 to 2. All right? And in this case, you can think of this as being this curve minus this curve. So we're going to do the integral from -3 to 2 of and the nice thing here is we already have this thing in terms of y, because this was 4 minus y squared. So I'm going to have 4 minus y squared minus y minus 2 dy. And that covers this whole area that we're interested in. We got everything in one nice little simple integral. All right, and so now we do some algebra to clean this up. Integral from -3 to 2. And I'm going to have a 4 minus y squared minus y plus 2 dy, and I'm going to go ahead and continue to combine like terms as much as possible. So I want to have the integral from -3 to 2 of 6 minus y squared minus y dy. And you notice this is really nice because all we got is a rewop. I'm going to let you do all of this. But when you do all this, you end up with 125 over 6. So anytime you have something like this, where it looks like something that's turned over on its side, try to come in, solve this thing for x equals, and then do your integration with respect to y. And it can make your life a whole lot easier. So this is the first part of 7.1. This will set you up to keep going. Now remember, I did some extra stuff on this, so make sure when you look at it that you come back through and read the instructions on for each problem and only do what you're asked to do.